Since the normal distribution is a probability distribution, we can do anything we've ever done with any probability distribution with the normal distribution. For example, suppose x is normally distributed with mean 5 and standard deviation 2. Let's find the probability that something is less than 1. So we can solve the inequality to give us a quadratic equation using the quadratic formula we find. Note that if x is 10, which is to say beyond this upper limit, the inequality is satisfied. And likewise if x is 0, but at x equals 1, the inequality is not satisfied. And so the inequality has solutions. Consequently, this event corresponds to the union of the two events, which, because they are mutually exclusive, we can split that probability. And since we're assuming x is normally distributed, we'll compute our z-scores. This is the probability that z is less than some negative value, which is the same as the probability that z is greater than the same positive value, which is complementary to the probability that z is less than that amount, which we can look up in our table, and we find for the other value, we find a z-score. And so that's the probability z is greater than some value, which is complementary to the probability that z is less than that value, which will be and so we can add them together to get our final probabilities. Or suppose a company's profit is normally distributed with mean and variance. And let's see if we can express the probability that the profit is at most 60, given that the profit is positive. And so this is a conditional probability. And so if we let the profit be the random variable x, what we want is, so we're given the mean, and remember the variance is the square of the standard deviation, so we also have the standard deviation. And for this interval, we can find the z-scores. So the probability that z is greater than negative 5 is the same as the probability z is less than 5, which we can look up directly from our CDF. And so the probability z falls in this interval is the same as the probability that z falls in the reflected interval on the positive side. And that's going to be the region to the left of 5, from which we'll remove the region to the left of 2. And so we find, and so the quotient is going to give us our conditional probability.